Hey guys, welcome back to my channel. Thank you for making this click. I really appreciate you being here. Remember to give me a thumbs up as the video goes along. So for the first question, it says, well, it gives us a diagram, basically a right angle triangle. They label the sides A, B, C. They give an angle at the point, so that will be B, that will be A, and that will be C. So they label the sides according to the vertex that you're seeing here and angles there. So it says, using the diagram above, express C in terms of A and B. So when they say express C in terms of A and B, guys, whatever you're going to express it into should be C equal something, something. All right? So we know that there's a relationship between A, B, and C where Pythagoras Theorem is concerned, where it says the length of the two short sides square is equal to the hypotenuse square, which is the longer side squared. So for this question, you need to know about Pythagoras' theorem. Because we can't say Pythagoras theorem. All right? So let's get into it. So we know that C is the hypotenuse. So we know that C squared is equal to the length of the two short sides squared. That means A squared plus B squared. But we want C and not C squared. So what we have to do here is to cancel the square here, which is to find the square root of both sides. So find the square root of this side and this side. So the square cancels the square root. So C is equal to the square root of A squared plus B squared. All right, and there you go for your answer. The next part of the question says, I'm going to leave this down here because we're going to need it for that question. So it says, write in terms of A, B, and C an expression for sine theta plus cos theta. So for here, guys, we need to know the three trig ratios, SOHCAHTOA tower. So ka tower. So we only need the sine and the cos or the cosine here. So we know OH means opposite over hypotenuse. So sine is going to be the opposite over the hypotenuse. Cos is going to be the adjacent over the hypotenuse. I'm going to say ADJ over the HYP for the hypotenuse. All right. So how we do this, guys, is since as we're given an observed angle here, we are going to label the sides of this triangle based on the angle they gave us. So we know that the side opposite to the angle is known as the opposite side. All right? So that's the opposite side. The side that is sitting on the angle or adjacent to it is known as the adjacent side. And this side is known as the hypotenuse. All right? So I must make this clear to you all that you cannot go ahead and label the opposite and the adjacent if you're not given an angle. You have to be given an angle in order to know what the two sides are. Okay? So the hypotenuse is basically a given because that's the longest side of the triangle. So let's continue. So the opposite side here is represented by the letter A. So we're going to have A over C here is the hypotenuse. So that's C. It's flat 9, but it's A, guys. That's A. And for the adjacent, it's going to be B. And the hypotenuse is C. So it's B over C. So it's A over C, sorry, plus B over C. If you want to simplify, you can say A plus B over C. So R, A plus B over C. All right. So that's it for that question. Let's move on to the next one. So the next part of the question says, using the results from part 1A and B, so meaning the answer that you got here for C equal whatever. So I'm going to put this on the paper here so we can move on from that page. So C is equal to the square root of A square plus B square. And the result we got from part B is that sine theta is equal to A over C and cos theta is equal to B over C. So using those two, guys, we need to go ahead and show that sine theta squared, or sine, yeah, plus cos theta squared is equal to 1. So here we're basically proving a trig ratio, a trig rule here. So let's go. So sine theta squared, so tan theta is a over c. It's going to be a over c, and that's a squared, plus cos theta squared, what cos is, b over c, says b over c squared, and that's equal to 1. All right, let's put it's not the thing, so you know we don't confuse it. All right, guys, and that's equal to 1. This paper is moving, I don't know why. So that's equal to 1, guys. So from here, we are now going to simplify. So we know that a, once it's to the squared or to any power, we multiply that thing twice. So a times a to the square is going to be a squared. C to the second power is going to be c squared. Plus here we have b squared. So it's going to be b squared. All over c squared is equal to 1. For this part, guys, we can simplify it. Since as they have the same denominator, we can go ahead and simplify. So we can say it's going to be a squared plus b squared. Paper don't move. All over c squared. Okay, so having this, we now can recall that c is equal to, or you could even have the c squared as well from the previous one. But what I'm saying here, you could use the c squared from here to write it, or we just use whatever we have here. So c is equal to the square root of a squared plus b squared. That means I'm going to recall that c is equal to the square root of a squared plus b squared. That means where I see c, I'm going to put all of that. So a squared plus b squared all over the root of a squared plus b squared, and it's going to be in parentheses to the second power. Why? Because c is squared here, and that's c. So this square cancels the square root. So remember to say it's equal to 1. I keep leaving the 1 off. So right here, guys, we now are going to simplify. So we have a squared plus b squared all over a squared plus, it's moving, a squared plus b squared, and that's equal to 1. This will cancel this. Therefore, 1 is equal to 1, and it's proven. Okay? So there we are for this question. Thank you very much for watching. Remember to like, share, comment, subscribe, and tell a friend about me. Then come and ask questions, make requests, and I'm here to help. I am in need of paper 3, guys, from the 2020 paper. If you have that paper, guys, can you share with me on my Instagram? Someone asked me to work the question for them, but I don't have the paper and I'm looking for it and I can't find it. So I'm asking if you have it to share with me on the on the Instagram at alka_quaint or Alisa Kennedy on Instagram. You'll find me there. Alright, guys, so thank you very much for watching. I'll see you on my next video.